Hi guys, I am Ankit. In this video, we shall see another problem in LeetCode. 132 pattern. So given an array of n integers, 132 pattern is a subsequence of three integers such that nums of I, nums of j and nums of k are given. And the condition is I lesser than j lesser than k and also nums of I less than nums of k, that is less than nums of j. So return true if there exists a 132 pattern in the nums array, otherwise return false. The question clearly says is that we have to find the subsequence pattern here. So what do you mean by subsequence? As I said, explained in very earlier videos also. So if I need to take an example, let's say 1, 3, 2, 4. Could say 1, 3, 2 is a subsequence, 3 to 4 is a subsequence, 1 to 4 is a subsequence. But if you take into consideration 2, 3, 4, no, this is not a subsequence. What the reason behind is subsequence is nothing but it's a part of an array. You it is we obtain the subsequence by deleting some of the elements from the array. Either you can delete 0 or many elements. So but we delete some elements. What do you mean by deleting element? So 1 to 4, how do we get this 1 to 4 subsequence? By deleting 3. If we delete 3 from the array, you get 1 to 4, the remaining elements. So that means you pick up the elements from the array, but the relative order of the elements with respect to the original array will remain the same. That is what subsequence means. If you see 2, 3, 4, first comes 2, okay. Next is 3 here, but if we see in the original array, first is 3, then 2 comes. So the relative order is not maintained here. That's why this cannot be subsequence. But if we see 1 to 4, 1 to 4, the order is being maintained. So that's why this can be a subsequence. So this is what subsequence is. In the given question, what they tell is, we have to find a pattern, 132 pattern. 132 pattern means what it means. You can see 132 number says 1 is less than 3 and the next number 2 which is greater than 3. So we have to find a pattern in the array such that if there are three elements, this should be the highest element and this should be the second highest, this should be the third highest. That means first element that should be less than the second element and the second element should be greater than the third element. So this is the pattern which we need to find. So 1, 3, 2. Okay. 1 means the smallest, second smallest, this is a yeah, and the highest one. So this is what we need to find the pattern in the given question. So if you take 1, 2, 3, 4 example, can you find 132 pattern here? Not in terms of number 132. It means um, a number such that number at index I, J, K, where I less than J less than K have they have told. So 1 less than 2 less than 3. We have to find three indexes such that the element at this index will be the smallest, this will be the highest, this will be the second highest. Okay. Sorry if I get confused. So clearly I have mentioned with this. You have to find an element such that smallest, second smallest and highest number. So they should be in this pattern, first, third and second. So how we can solve the question? So if we take the second example, 3142, can you find a 132 pattern here? Yes, we can find a 132 pattern. So 142 is a subsequence which we can find here. 1 is the smallest, then the second smallest is 2 and the highest one is 3. So they are following the order, right? Smallest, highest, second smallest. If we take this smallest, highest, second smallest, right? So in the middle element should be the highest, next highest should be the last element, and the smallest element, next highest should be the first element. So this is what we need to find the pattern. We have to look for this pattern in the array. So what is the approach to solve the problem? So what we'll do is, okay, we'll just take an example. Okay, we'll take the same example. We'll take simple example 3142. Okay, and let's have a variable maximum value. Why do we require this maximum value variable? I'll tell you. And let's initialize it to maximum value since we have to find. We'll initialize it to int minimum. That is integer dot minimum value in Java we tell. Int minimum in C++. So maximum value we'll initialize to int minimum and we'll have a stack, empty stack now. Okay. And start iterating from the end of the array. Why? Even that reason also I'll explain you. So start iterating from the end of the array. So first 2. Okay. Now 2. Is it present in the stack? No. Anything is present in stack? Nothing is present. So just insert. Fine. So next element. Move to next element. So next element is 4 here. So now check whether 4 is less than int minimum, max value will not check that now. So first check the stack is empty. No, stack is not empty in this case, and you can find the element that 4 is greater than 2. So what we do is we replace, since 4 is greater than 2, we have found the maximum value. So what we do is, since we have got a greater number that is greater than the previous number in respect of the end of the array, the maximum value we reinitialize it to 2 now. Since 4 is greater than 2, we will reinitialize, and the stack is not empty, we will reinitialize maximum value to 2. But you might ask, why do we need to replace the maximum value to, don't we need to increment the maximum value to 4? That reason also I'll explain. So we will increment the maximum value to 2 now. Okay. Now pop this 2 from the stack and insert 4. Okay. So that's it. Next you find 1. So next, once you find 1, so is stack is empty? No, stack is not empty. Is 1 is greater than the maximum value 2? No, this is not maximum value. But it is less than 2. So return true in this case. So the main intention behind doing all these things is we're just finding at the beginning. What we do is we start iterating, right? If stack is empty, you insert 2. You find an element from the end in the back of the array such that ith and I plus 1 position is that the ith value should be greater than I plus 1 value. So here 4 is greater than 2. So we look for this element first. So initially stack is empty, insert. Next, when you get 4, check that 4. Okay, the stack is not empty and that 4 is greater than int minimum, that is nothing but max value. Yes, it is. And stack is not empty. That means, what does it indicate? This indicates that we have found an element that is greater than the element which is already present in stack. But you might ask, why are we not initializing max value equal to 2 here? Because that is greater than int minimum? No. This max value indicates what is. So if we are at this position now, the maximum value which we the element, okay, once you found an element which is greater than I plus 1th element, the next value which we will be looking in the array will be greater than this element, right? Not this element, because this is the highest element, this is the second highest. We will look an element that is not greater, smaller than the second highest element. So that is why we initialize max value equal to 2, not 4. Got it? So what we do intuition is, I'll explain once again. So this, so we have maximum value initialize to minimum now, int minimum, and this stack. So at first, what we look into the array is we look for an element in the array such that ith value should be greater than I plus 1th value. Here it is correct. Why are we looking? Because we need a pattern 1, 3 to pattern. That means this value should be greater than this value. And next you look for an element which is smaller than the second highest value. So that is when you find an element that is greater than the I plus 1 value, you initialize max value equal to 2, so that you can find an element in the rest part of the array such that it is smaller than the second highest value. Okay. So if I need to tell again, at first, you look for an element that is greater than the I plus 1 value. Once you find that, you initialize max value equal to this I plus 1 value. Why? Because we need to look into an element in the rest part of the array such that if we found any element that is smaller than this I plus 1 value, then we can confirm that we have found a subsequence of pattern 132, because here you found a greater element than this element. Now max value is this. We look for an element that is smaller than this value. So if you find such element in the rest part of the array, we will get the subsequence of 132 pattern. So for doing that, we have this algorithm. How? As I said, 1342 we have. So that is the reason max value you initialize it to int minimum now. So you don't update it to 2, because only when you find an element that is greater than this 2, then only you update it to 2. Initially you won't update it to 2. So, and that when you update it to 2 is because when the stack is not empty, 2 is present in stack. That means you have found an element in the stack, and this element also you have found which is greater than 2. So that's when you update the value to 2. Otherwise, you don't update the value maximum value. You update maximum value only when you find an element that is greater than I plus 1 1th element. And when you find an element greater than I plus 1th element, so whenever you iterate over there, if you find an element that is less than the max value, that means second highest element, you just return true here. So you might ask why we iterated from back of the array? Can't we do implement the same logic in the from the beginning of the array? But if you implement same logic in the beginning of the array, so you start here, stack will be empty. Here you have to look for an element 1 3 to pattern, right? So for here we will look for an element that is greater than the ith value should be greater than I minus 1th value, right? So here look for an element I minus 1th value is less than the ith value. So 3 1 4 here you found here. If you can find here, no, 1 is less than 4. Okay, that is consider. We will consider that now. So if you consider 1 is less than 4, next second highest will be next you have to look for an element in the remaining part of the array such that it should be greater than I minus 1th value and less than ith value. 2 should be greater than 1 and less than 4. So two conditions you have to take into consideration. But when you iterate from the back, once you found the highest element, the second highest element we have, you need to find only an element that is less than second highest. That's enough. You need not to take into this into consideration. But when you start from beginning, you have to find for an element, look for an element that is greater than the smallest element and also less than the highest element. So that is the reason. So this is the logic. So we shall implement this now. Let's say let n be the array length. Okay. And one more thing, they have given n size, the length size can be greater than less equal to 1 also. So if n itself is less than 3, that means you can just return false. You will not find a subsequence of 1 3 to pattern, right? So later we'll create empty segment. This becomes false. Then we'll create an stack. So let's stack of type st. Okay, this should be small letter. And we'll initialize a max value equal to int minimum. So in Java, we use integer dot minimum value. So now iterate over the elements will be I equal to n minus 1, I greater equal to 0, I minus minus. As I said, what we do at first, if stack is not empty and if you find nums of I, that is here you are finding, that is less than the max value. Then what should be done? If that is less than the max value, then we have to do the thing. Max value will be initialized to stack.top, because when you find 4, that is less than the int minimum, right? I mean greater than int minimum. So yeah, it should be greater. So that time you initialize max value equal to 2, which is already present in stack. So that's why you initialize max value equal to stack.top, and you can pop the value from the stack also now. 2 can be popped out. So later we have to push dot push of nums of 5. 4 should be pushed into stack. And when you return true, when you find this element which is less than the max value. So if in case nums of I less than max value, if initially we have max value equal to int minimum, then it any number greater than that only will be present. So that time this case won't be happen. This case will happen only if you find an element such that greater than the next element. So return yes, or else return false. We will run this. Okay, this is returning true. Let's check. This it will find an element n minus 1 then nums of I. Okay, stack is not empty and nums of I. Okay, it should not be greater than max value. It should be greater than stack.top. Why? 4 should be greater than 2. That is the reason. That's why we are popping it and we push 4 into the stack later. So Initially you should find an element that is greater than its next element, that means stack dot top. So I think, yeah, that's it. We can run this and check again. Yeah, so we'll go through the Java logic also. Same thing, you initialize stack max value. If you find element less than the max value, return true, or else max value will be stacked on top and push the element in the stack. We will submit this also. Yes, successfully submitted. If you understood the concept, please to like the video and subscribe to the channel. We'll come with another video in the next session. Until then, keep learning. Thank you.